Hi, this talk is how to build an insecure system out of perfectly good cryptography. And the point is that, yes, it's good to worry about provably secure crypto, but there are so many other issues in real life that are, really serious system issues that people don't tend to think about. So website names. So a website gets a name, like Dell.com would be a name. And there's some registry organization that administers each top level domain. So for instance, there's .com, .org, .tv. And the website can choose which top level domain to get a name in. So if it turns out that whoever's giving out names in .com is charging too much, you can get one in .org or .biz. So if a name string within that top level domain is available, usually you can purchase it. Sometimes, like with .edu, which is supposed to be for colleges, and .gov, which are government things, it might be more strict about letting you choose a name, that the name really has to have something to do with your purpose. And then once you get a name, there's lawsuits and people selling names, and that makes things interesting. So a website has a name. The theory is beautiful. So the client wants to talk to a website that has the name x.com. The client sends a message, rux.com. The website sends a certificate, and then there's cool crypto with some sort of handshake. And then they have a cryptographically protected conversation. So that's beautiful theory. It all works. But in reality, usually the user doesn't start with the DNS string, and instead the user does some sort of search and gets some sort of obscure URL string. And that's an actual URL. A human would have no idea what that means or care. Even if the user does manage to find the DNS name in the URL, I actually fell for a scam recently. So I wanted to renew my driver's license, and I knew it could be done online. So I did an internet search for renew Washington State driver's license. And I got search results, and I clicked on the top site. And I do understand the underlying protocols on the crypto, but I was tired and I was in a hurry, so I just clicked on the top site. It didn't occur to me that the top site wouldn't be correct. So this is what the top site was. I didn't notice that it said add, but even as such, often the top legitimate site also pays to be first in the order, so it might say add. And the DNS name, if I had looked at it, looks perfectly reasonable for renewing a driver's license online. So after I clicked on it, everything was as I expected. I had tabs there for I could click on renew my license or get a new license or replace my license with all these nice, happy people in the pictures. So I clicked on renew license. I typed in all of the information that it asked, and it asked things that I expected it to ask, like what's my address, what's my driver's license number, and what's my credit card. And so after I completed that, I then got a little suspicious because then it said, here's a bunch of offers that you are now qualified for. And then I looked more carefully at the site, and it just claims to give information about how to get a license, not actually getting a license. One of the offers was a free download of an ebook that would tell me how to get a license, which if these guys were at all honest, would have been, hey, this is the URL you actually should have gone to. So I also noticed they didn't say how much they were going to charge, but immediately they charged $3.99, and then $9.99 the next day, and then $19.99 the next day. So the bank fraud department called me up and asked if they were legitimate charges, and I explained the problem and what had happened, and the bank disallowed the charges and gave me a new credit card number. So I was not harmed in any way. Actually, I cherish this example because it really makes people realize the gulf between the real world and the theory behind the protocols and the crypto. So you shouldn't blame the user. The scam sites can appear first, either because they paid the search engine companies, or if they understand the ranking algorithm, they can game the system by having lots of pointers to their site. And at the time that I was duped by this, there were several similarly deceptive names, and there were variants of it for all 50 states. So like UtahInformation.org or IdahoInformation.org that all appeared before the real site in the search order. So there were things like yourdriverslicense.org, Washington Driver's License Renewalonline.com, DMV.org. The site I should have gone to was that. Now, why should I, as a human, just know that the other names were fraudulent names, that you can't expect a human to know that? So this particular scam, actually, I believe, finally, they shut it down because I can't find these sites anymore, but it does show that all of the wonderful things that in theory work can be irrelevant. So unfounded assumptions that DNS name makes sense, like that it must be Dell that owns the name Dell.com, that users will know the proper DNS name for a site, that users won't be tricked by absurdly complex URL syntax, or they won't be tricked by a tricky DNS name. Like for instance, in my example where it looked like a logical name, or you can use the actual DNS name, but substitute foreign letters, like the Russian S in place of an English C that looks the same. So like Microsoft.com, actually, the actual name can be a different string because the C is the Russian S, and it'll look particularly, perfectly fine to a human. So another issue is certificates. So a certificate is a message that contains a name and a public key signed by a trusted entity known as a CA. And the way that it should work is that when you buy a DNS name, the same registrar that gives you the name should also give you a certificate for the public key associated with the name. While you've actually authenticated to it and paid for the name and you're talking to it, that's the point at which you should be able to get a certificate. But no, the entity that gives you a certificate has no relation to the entity from which you actually got the name. So the way you get a certificate after you've gotten a DNS name. So let's say I got the DNS name radia.org. So nobody's really documented how this has to work. And so there's various types of kludges that people have, that CAs have implemented in order to let you prove that you own the name that you're asking for a certificate. So one method that's commonly used is you go to a CA and say, I would like a certificate. I have the name radia.org and my public key is this number. So the CA looks up radia.org in DNS, finds the IP address, and then sends you a message. And so if you can receive a message at that IP address, the CA assumes that you own the name. So it signs a certificate and gives you the certificate for radia.org with that public key. But if being able to receive at a particular IP address were secure enough, we wouldn't need certificates. Just put the IP address in DNS, and if people can talk to you at that address, you've proven you're you. This is an extremely insecure mechanism. So the CA is also supposed to do revocation somehow in case your private key gets stolen. And even if the CA does have a revocation mechanism, most browsers don't bother checking because it would add delay and annoy users. Now, certificates do have an expiration date, but the only thing that the expiration date in a certificate accomplishes is a revenue stream for the CA. Having a certificate expire after a year is way too long if you've actually had your private key stolen. And so it really does not work as a revocation mechanism. So standards. When there are similar standards, I'm always really curious about how A compares with B, but it doesn't seem like anybody ever does that. So there's either people that know A or there's people that know B. And if I ask somebody, how do they compare? They have no idea. They don't really know what's in B. So I have to start with these two specifications that are both hundreds of pages long with their own jargon for no good reason, and try to read them and understand the differences. If I ask an expert in A how it compares with B, they say, excuse me, that A is awesome and B sucks. And if eventually the world is sort of debating about these things and the people in the A committee hear about ways that B is better, no problem, they steal all of the ideas. And so both A and B are moving targets. Nobody cares what's actually in their spec, they just want credit for it. So the way that I tell people to understand standards body, it's natural to think of them as well-educated technologists that are carefully weighing engineering trade-offs. But I tell people, no, a much more accurate way to think of them is as drunken sports fans, rah, rah, our team. So, but here is an example where instead of doing what standards bodies usually do, which is inventing their own thing, a standards body actually adopted a syntax invented by a different standards body. So ordinarily, I would applaud them, but in this case, it was a bad idea. So a certificate format, what is a certificate? Well, it's a very simple thing. It matches a name to a public key. So it's a message that said, Radia's public key is this, signed by the CA. So the IETF working group on standardizing certificates decided to base their certificates on X509, which was a standard done by a different sports team. So I claim this was a bad idea. Now, why should it matter? Well, the problem with X509 is that it maps an X500 name to a public key. So what's an X500 name? Well, it's a perfectly reasonable hierarchical namespace. A hierarchical namespace has components just like DNS names do. Their components actually have types. So a type of a component could be C equals, which would be a country, or O equals an organization, or OU is a unit within that organization. And the bottom part of the hierarchy is a common name, which could be ignored. So X509 would have been fine as a certificate format if internet protocols and users were using X500 names, but they don't. They use DNS names like labs.examplecompanyname.com. So what good is something that maps a string that the application as user is unfamiliar with to a public key? So here's an example. The human types foo.com or clicks on a URL containing that DNS name, and the site sends a certificate with an X500 name, like C equals US, O equals Attica prison, OU equals death row, OU equals particularly vile prisoners within death row, and CN equals horrible person. So what is the browser supposed to do, given that the string in the certificate is different than the DNS name that the user typed? Well, one strategy used by some implementations where ignore the name in the certificate because you can't match them, but validate the math of the signature. So what security does that give? Just the warm, fuzzy feeling that somebody paid someone for a certificate. So people invented at least 3 different ways of encoding a DNS name into a certificate. One was have a new category of name called DC, which stood for domain component. So instead of C equals or OU equals, you'd encode something like labs.emc.com as DC equals com, DC equals EMC, DC equals labs. Another different way of doing it was there was a field in the PKIC certificate called alternate name, and you could put it there. Or you could use the bottom of the X500 name, the common name, to put in the DNS name. Are 3 ways better than 1? No. Suppose a CA enforces that you own the DNS name in the common name field before it signs the certificate, but allows you to put whatever you want into the alternate name. So this could be a security problem. Today's browsers tend to accept the DNS name encoded in either the common name or the alternate name and ignore the rest of the X500 name. But do all CAs enforce that you own the DNS name encoded in any of these places? So the last topic is, what is truth? So in the olden days, content would be signed by some well-known entity, like a major news station. Now, actually, it's not signed, but we can fantasize that that's how it should have worked. And but now everybody is a reporter, which is how it needs to be, because when news is happening, there'll be somebody with a cell phone, some unknown person, and the Channel 4 news team is not likely to be there. So it's very important that anybody can inject information. So, but having a digital signature for whoever created the content is irrelevant, because no one knows who the source is and whether there's reputable. Plus, photos and videos can be faked. Plus, on top of all of this injection of fake news, machine learning wants to keep you watching. So they feed you more things that you seem to like. And so that makes people more and more polarized and isolated from any information outside of their bubble. So the pessimist in me says, as a result of all this, this is the end of civilization. The optimist says, hey, you guys need areas for research, right? So it's great that there are problems to be solved. So I'm going to end on a quote that I actually wrote. It's in my textbook, and I think it really captures what people should take to heart and keep in mind. Humans are incapable of securely storing high-quality cryptographic keys, and they have unacceptable speed and accuracy when performing cryptographic operations. They're also large, expensive to maintain, difficult to manage, and they pollute the environment. It is astonishing that these devices continue to be manufactured and deployed, but they are sufficiently pervasive that we must design our systems around their limitations. So don't blame the users. You have to figure out how to design things that will work with humans. So thank you, and that's the end.
Thank you very much for this exciting and interesting presentation. By the way, the presentation of Radia was recorded because it's so early in the US and today is also Thanksgiving. So Radia, happy Thanksgiving to you. We have a lot of questions for you, a lot of questions. And I have also questions. So I will start before we start reading the questions from our audience. So essentially, one vulnerable or untrusted CA makes the entire ecosystem vulnerable, right? So could we replace CAs? Would you recommend that we use a single CA? For instance, now we have Let's Encrypt, and this is rapidly growing. They already control like 35% of the CA market share. Would you recommend getting rid of CAs at all? Would you recommend using one CA? What is your solution and recommendations to cope with these issues and security vulnerabilities that multiple CAs introduce?
Actually, I have a whole talk about trust models for PKI, but the simplest answer is if you get the name signed by whoever gave you the name, that would help a lot. But yeah, I have sort of arguments about how the whole CA thing should be very different. Instead of just completely believing any of the trusted CAs for any name. Instead, a CA should only be trusted for certain names.
That's a good idea. So another question from us, and directly following up on your last slide, how do we design and build systems around the limitations of the users? You know, human error is the main factor for vulnerabilities, privacy issues, security issues. How do we build systems around the limitations of users and systems that would be user-friendly?
Right. Well, to start with, engineers should actually like meet some humans. And so I'm amazed at how bad everything is. So like I was trying to install an email browser or email client, and it asked me whether I wanted POP or IMAP. Now, why should I care? What does that even mean? I happen to know it's two different standards, but you know, that's not the kind of thing you should actually ask people. So one of my pet peeves is that people say, we need more user training, and blaming the user is not the answer to things. So it is extremely difficult problem, but yes, we have to do something because, you know, given that horrible example where I was completely taken in and gave my credit card number to a complete criminal, it's something that people need to pay more attention to.
Right. That's true. So what role or responsibility do you see for lawmakers in this government, lawmakers? Can they influence or change something?
Well, I'm really surprised that if somebody makes a toy and some kid manages to do some bizarro thing with it and pull it apart and leave it in the sun and choke on a piece of it that came off as a result, the company will be sued, you know, and go out of business probably. Whereas with software, you click on this, you know, EULA, this end user license agreement that nobody reads. And if you actually do read it, it basically says in legalese, look, I'm selling this to you. I told you that I'm not warranting that it does anything. I told you you were crazy to even try to buy it, but you insisted. So it's not my fault if anything goes wrong. It could be that if people sue software, we're able to successfully sue software for bugs that are security issues. But even that, you know, like whose fault was it that I got taken in by a DNS name that looked reasonable? It wasn't any bugs in the operating system or in the browser. So I'm not, I mean, certainly there should be laws that saying that running a scam site like that purely for collecting money from gullible people, that should be illegal, but it's very difficult to track these people down. So I'm not sure what the answer is.
Do you think automation would help?
Automation? You mean getting rid of people entirely, replacing us
right.
with
well,
computers?
getting rid of expecting a user to provide his input to something he doesn't know, or installing things he doesn't understand, automating this for the user.
Maybe that would be a great thing for researchers to do. So they did things like have the URL screen turn green if there's a certificate. But yeah, in my case, it would have turned green. So yeah, the more things you could do in terms of warning users, I guess that could help. As I said, there's all sorts of opportunities for research here.
Right. So thanks a lot. Now, Radia, you're staying with us. Since we're pressed in time, we are moving on to the panel. And our audience is welcome to ask questions. You and Svea, who is going to join us back. Hello, Svea. Great to have you again. Now, the two of you, Radia is coming from the research and industry perspective and standardization, and you are investigative journalists. There is a lot which the two of you together could recommend as improvements? And of course, our public audience has a lot of questions for the two of you, but let me start. So first, a really question which I get from both of your talks actually, this is the main point. Human error is the main factor for vulnerabilities, for security issues, for privacy issues. What can you recommend, and not just looking at certificates, right? Just in, in general, how can we cope with this? So you are saying correctly, maybe educating the user is not the only thing that we should be looking at. So what are your recommendations there?
Thank you very much. Yes, this is also the question which grew in my mind during your talk, Radia, that this is also what I think. We cannot blame the user. This is also what I think, because I sometimes think we cannot always say, yeah, the user has to look this, the user has to look that, because I'm thinking about very young users like school children, or you think about very old users like grandmothers. They also want to use Skype, they also want to use Zoom, and you cannot burden on them to, to secure against anything. In my perspective, in my opinion, I think it's a thing for lawmakers and politicians. I think they have to make laws that they can charge or that they can investigate companies who, for example, selling data, or that they can charge criminals and or companies who are not implementing good security. So this is my opinion.
That is an excellent recommendation, but this is a topic and entire debate topic on its own, because when the politicians make recommendations, they do not have the technical understanding how to put it to life. And often the policies or recommendations either do not make sense in practice or very difficult to deploy and enforce. So that is a really challenging thing, how the research or the industry could work together with the politicians to derive these things, or maybe the standardization entities like the IETF. Radia, what do you think?
Well, in the old days, where I communicated with a telephone, people could call me up and annoy me. They could trick me into doing things, but they couldn't destroy my phone. And these days, everything that you do involves browser extensions and other ways of downloading malware. It's bad enough that the underlying thing you start out with probably has bugs that, due to no fault of mine as the human user, people can figure out ways of infecting my machine. But the fact that you really have to interact with the world by clicking on complicated URLs in email strings, because it's just too hard to actually start from scratch at the clean URL and go through 7 levels deep. So yes, my bank sends me emails saying, click on this, and I do. And also this whole thing of browser extensions. Why would anybody want to do that? I don't know if I have any browser extensions other than what my company's IT department has installed. But that is sort of one dangerous thing, that in order to really function, users are actually downloading software.
I think sometimes it is that you have the laws. For example, now in Europe, we have GDPR, but you also have to have the people who enforce the law. For example, we have data commissioners, and but I know, because I do very often interviews with them, I know that they do not have so much money, that they do not have the capacity to reach over to foreign countries to pursue the user's rights. And so I think these are also two components, I think, which are important. So you have to have the laws, the European laws or the international laws, but then also you have to have the people who can enforce it and to go after the cases.
Now that's an interesting suggestion. I think here's a question. I'm working on one of the research topics that I'm working on is Darknet. And we are investigating what attacks there are in the Darknet what is being sold, rented, what kind of data about us, normal people, is traded in the darknet. And what I noticed is how good these darknet marketplaces are protected. You have such wonderful usability studies that they must have done. When you log into these websites, they explain to you everything A to Z. They tell you what you should do, what you should not do. And in every step that you're doing, they are exactly guiding you how to do that. And this is excellent, simply. And you cannot compare this to things like Amazon or eBay. So do you think we could learn something maybe from the criminal side, from the darknet? What are your opinions on this?
I'm not I'm not sure how to answer, so I'll defer at least while I think about it.
Okay, Svea, do you have an opinion? Have you seen the darknet? How it is? You could buy a lot.
I found this a really interesting suggestion. So I was kind of perplexed because the first thing you said, how good they are organized, I totally see that, because we have the same thing with ransomware, where you have this, super call centers in place. Oh yeah, here, you gave us the money. Here's the key. Oh, you need support? Yeah, we give you support.
Exactly.
So this is what I got and what I thought. Yeah, and you thought about and said, okay, yeah, can we learn something from this and the. In this thing, yeah, I think in this way, yes. And the other thing, what I thought was, sometimes I also do investigation research with cyber police, and also talking to people who are investigating darknet from the police side. And what some of them tell me is that they can hardly access the darknet, that it's really hard for them to access it from their bureau, because they need a second line, an extra connection, and that police often is not so well equipped and so well connected over the borders. For example, if you think of the darknet, then they are criminals. They are working around the world. They are super connected. And then when you think of our German police sitting in Hamburg, sitting in Munich is a problem. And then next step is, okay, sitting in Paris or in Singapore. And this is also, I think, yeah, this and I think in this way, of course, to follow up with the speed, of course, we need to learn from criminals, because they are connected internationally. And if investigations want to follow up on the speed of the criminals and on the speed, of course, they need to connect themselves. But I know that this is really hard. I know it from the investigation side that it's not easy to connect over borders.
One of the reasons I didn't know how to answer that was I really haven't gone to the darknet to hire a hitman or whatever it is there. So I really
didn't say they sell hitmen. How did you know about that?
Right. So I haven't experienced this delightful customer service stuff. And if indeed they are good, people should take pointers from them. But something else, like people say, oh, privacy is so incredibly important. And yes, I agree. But every time I hear about some horrible criminal that the police were able to track down because they could track where their cell phone was, or they could look in their browsing history and catch them, I'm actually really pleased. And you sort of can't do both. So either you have this police state where nothing you do is private, and if you ever do anything bad, the government can track you down, and they'll never prosecute a innocent person or let a guilty person go. That sort of sounds good, but on the other hand, of course, that's a slippery slope where not all governments are benign.
Yeah, that's certainly true. That's certainly true. So, but bottom line, I guess, there is something that we could learn. I started doing this research with the darknet since 2018 with my team. And yeah, so first you see all these goods, and it's amazing how accessible that is, but how good protected it is. You cannot compare protection that Amazon uses or the usability and user experience with the darknet. This is simply amazing. I think the white hats have a lot to learn from the dark side, and I guess maybe they're so much better protected, but because there is so much at stake. It's not just the money that they will lose. If they are discovered, they will also go to jail. So maybe when there is much more at stake, people care much more about the potential vulnerabilities and attacks. By the way, they also have bounty programs. They offer bounty programs. If you find bugs in their services, you get awards.
Yeah.
It is really amazing. Yeah.
They are mirroring also. They are mirroring, and I see it the way.
Maybe the other way around. You know.
Yes,
maybe
I see
they
it the
started
way.
this.
They see, okay, eBay. How is eBay working? How is Amazon working? You know, all with the recommendation system and the stars you get when you are a super seller, premium, super best. And I know in the darknet they copycat this kind of things and see, okay, this is working for Amazon. Why this also can work for the dark. So I just want to add something to what Radia said, and I think this is really a very thin path or a thin slope we are going here, because we have this super surveillance on the one hand, where we say, okay, there should no darknet exist. There shouldn't be a Tor browser. Yeah, it should be. So this is the one extreme. And then you have the other extreme where you would say no freedom overall, and we let everything go. And we have a really discussion right now going on in Germany and in Europe on encryption, about messaging encryption. So should there be like some super key for investigators so that they can in the end decrypt messaging, what I think would be a catastrophe, or what I would think would open up the box of Pandora for several other problems. But I think it's like a thin line we are balanced. It's an act of balance we are on.
Mm-hmm. Radia, what do you think about this? This is a good point. How is this viewed in the US, and what is your opinion on this about encryption or backdoors for security? Yeah, you start with public security. We do this for safety.
I'm not sure I could speak for the US. Sort of.
Well, just how is the spirit there? You know, because in Germany or in Europe, this privacy is a very important topic. In US, the perspective is a bit different, I think, but you would know much better because you are there. So that's the question.
Right. Well, because we need to sell to Europe, we do have to worry about GDPR. When I read the GDPR rules, I mean, legalese tends to put me to sleep, but sort of look at it and say there's no way to actually do what they're saying. So what they're requiring is not technically feasible. So when you have laws that are written by non-technical people, you wind up into something where they can be selectively enforced. If the government wants to get you, they'll find something that you aren't doing because it's impossible. And most people can just ignore it. So I'm certainly not someone that should be speaking about this stuff because I don't pay that much attention to the, you know, well, I shouldn't even say that. Yeah, it's, does the US care as much about privacy? I'm not sure. I mean, most people wouldn't even know what that means. And it's security in general. You don't really care about it until your house has been broken into. So you know, you leave your house unlocked because the danger of being locked out is much greater than the danger of being broken into until you're broken into. Yeah, in terms of whether people want to have products that are really secure, whether it's technically feasible to build products that are secure, I'm not really sure.
We have a question from chat that to what you said, Radia, that maybe people, maybe that isn't part of the business model, that people aren't willing to pay for security and privacy.
Right, it shouldn't be a, here, we're selling you a product, and then if you want security and privacy, here you can buy this extra product. It should all, people would just kind of expect that the thing would be secure. And if it's not, it's a fault in the product, not that they should be buying extra services.
Yeah, Svea, maybe you could leak to us a little bit inside information. You interviewed Snowden. What did he say about that? We are really curious.
First of all, I have to admit or correct that because it was not for me possible to go as a person to Russia. So I did it together with a colleague and a colleague of mine.
Not letting you in.
No, it was just one person allowed. And so I teamed up with a colleague and so we developed the questions together. It was for we did a research on infrastructure, and we did a research about vulnerabilities and infrastructure, and asked him about what is NSA doing, what is Cyber Command doing, how do they implement things in the infrastructure, in the networks, to have some things, I would say, in place, that if something happens that they can react, for example. And it was very scary what he said on that, because what he was basically saying is that we are destroying the internet, or that we are destroying the networks with doing so. When our cyber commands or intelligence services, if they are going on and doing what they are doing, then they are building like some kind of loopholes where things can happen, where criminals can get advantage of.
It even happened recently, right?
Yes, it already happened.
Right.
And on the other hand, what he said, that it can be exploited from criminals, for example. And also that there can be incidents where innocent people can also be targeted, because you cannot be so precise on your attacks when you're doing this as a state, that, for example, that you can accidentally hit a hospital or something. So what he said was that
which also happened.
Yeah, that there's a great harm.
All of this happened, what you're saying.
The interview was in, it's I don't know, was it 2 years ago or 3 years? Some things had already happened, but some things hadn't, and they now happened.
Yeah. Wow. So our audience has a suggestion for those of you, and a question that if you thought about giving such talks at schools and to teach kids, and what can we as a society realistically do to educate kids from very young age to understand and cope with this software cyber issues.
Thank you. Yeah, this is very nice, and I do this. I actually do this sometimes for students or for older. So also for school kids, but for if they are in the last year, then I sometimes have an invitation, and then I do some screening and tell them a little bit about this. But I'm on the side of Radia, who says security has to be also built in the product, and I think this is, then we are back in the politics to enforce it, that companies that they build secure products, and of course kids have to learn everything, but I think it's also a company and a thing for lawmakers.
Radia?
Yeah, I'm not sure. I mean, I love actually teaching, and I think that one of the pieces of advice that I give to people is that you should be able to take a topic and an amount of time and a type of audience and tailor your talk to that. So I actually have recently given talks to non-technical people, to high school kids, to elementary school kids. And but the topic of how to stay safe online is not what I generally talk about. It tends to be sort of more, more technical talks. But it's not just how to stay safe online. There's all of these things like if somebody comes up to you at the playground and says, "Can you help me find my dog?" A lot of kids would, really love to help on that mission. So how to have kids be absolutely safe. Now with my kids, I decided that the risk of having them kidnapped by a stranger was so much lower than what they would lose in life by having great delight in talking to lots of people, that we didn't really emphasize that very much. So they were like very friendly and happy to talk to anybody. So yeah, I don't think you could teach how to stay safe to adults, much less to kids. And especially in these days when, you know, I just cringe at what the kids these days are willing to post on social media. But even if you don't post things on social media, the information about where you are and what you're doing and what you're looking at is gleanable from you, even though you are not consciously posting it. So I really don't have an answer to this.
Yeah, right. The problem, you know, it is convenience versus security issues. Like my device, the things this device knows about me, this is horrible. When I see this, on the other hand, it's so convenient to know where I was last month, what I did, how it changes where I need to go, how to find that. It is a trade-off. Now, our event today is coming to an end, and I would like to thank you both so much for taking part in this today.